the race to win wars and explore the stars have created some of the most fantastic products ever designed, and we use them every day, unaware of their amazing origins. On Wicked Inventions. Fire-resistant clothing, how a NASA tragedy led to greater fire safety. Camouflage, from battlefield disguise to high street fashion. Rope, a Navy essential that we've been using for thousands of years. We reveal the amazing science and manufacture behind these wicked inventions. Firefighters have to get dangerously close to fires in order to tackle them. It is not just exceptional training and bravery that allow them to enter these boiling infernos, but it is also the result of the NASA technology that their flame-resistant suits are made from. On January the 27th, 1967, a flash fire erupted inside the Apollo 1 command module during a launch pad test, which resulted in the death of the 3 astronauts inside. In the aftermath of the tragedy, NASA were determined to minimize the chance of a similar accident happening again.
After the fire in 1967, NASA redesigned the space capsule so that there was less flammable material, but where material couldn't be avoided that might be flammable, they encased it in polybenzimidazole, which was a polymer they used, and that was then later the technology that they had developed for that was used by firefighters, and it became a part of the firefighting clothing in the US. Since then, it's moved on to further polymers like Kevlar, Nomex, and Teflon, and that blend of polymers has also been used in spacecraft to coat wires and allow them to be less flammable in a very small confined space.
Polybenzimidazole fibers, also known as PBIs, had actually been developed by the US Air Force in the 1950s. But now NASA intensively developed their application in order for it to be used inside their spacecraft and incorporated into their spacesuits. But what made it such an important material?
The reason that the polybenzimidazoles work so well is that when exposed to fire, one of the main things they didn't do is they didn't melt and it didn't lose its strength, because it's a very long chain molecule, and long chain molecules by their nature entangle themselves a bit with each other, which means it's actually quite hard for them to melt. So basically it didn't burn and change properties during the presence of fire, which means you could use it as clothing.
Throughout the 1970s and 80s, PBI was instrumental in the US space program, and by 1977, the technology had been incorporated into firefighting clothing, where it still remains an important fire-resistant material today. Viking is a private Danish company that produce a wide range of firefighting safety equipment for many countries and fire departments since 1960. Based in Esbjerg, Denmark, the first stage of production for the Guardian suit involves designers using Gerber technology computer software, which sends brand new patterns and designs straight to the automated cutting machines in the warehouse. Firstly, multiple rolls of materials will be fed into the machine for cutting.
The Viking fire suit Guardian is a quite unique suit. The suit is designed in cooperation with Gothenburg Fire Brigade in Sweden. The suit itself protects, of course, against heat and flame, which is the main purpose of the suit. The design is that you actually can remove the outer shell while wearing the suit. This enables the firefighter to remove the outer shell when he finishes his task, and the outer shell is contaminated with particles. Then the outer shell can be removed while wearing the suit. It can be placed in a laundry bag. At the same time, we are not contaminating the trucks, the fire trucks, and the fire stations.
Once at the machines, multiple layers of different materials are stretched out, so the automated CNC machine can start laying markers for cutting. Once all the materials have been layered, the cutting machine takes over, first by making all the relevant holes and then cutting out the desired shapes of the material, including all the pockets and any special features that have been sent to the machine by the designers we saw earlier. The cut pieces are then gathered and packed so that they can be taken to the sewing and seam sealing rooms. The Guardian has an advanced layer and membrane combination in the suit called PBI fibre, which protects the firefighter from a wide range of hazards and harmful chemicals.
The PBI fibre mixed together with the Kevlar fibre actually have a decomposing temperature of approximately 800 degrees C. The next layer in the suit is the moisture barrier. The moisture barrier protects the firefighter from moisture, which means water and chemicals from the outside. This should protect him from the water, which can be hot when you distinguish a fire, and of course the chemical which you can be exposed to as a firefighter.
Even when the outer shell is removed, this special moisture barrier protects the wearer in many ways. Using a hot air welding machine, a worker welds a continuous seam into the jacket, which is not only waterproof, but protects against the 5 most dangerous chemicals, such as blood, bodily fluids, and petroleum products. This means it has to go through numerous tests before it can be completed. Because the garment is being sealed for waterproofing, strips of the garment have to go through regular pressure testing using a hydrostatic testing machine, where the membrane is exposed to a high-pressure column of water to ensure that it stays waterproof, even under intense water pressure. Once passed, production can continue. Further testing awaits the material for the main outer layer of the Guardian suit, using a seam strength machine. The tensile strength of the fabric has to be tested to live up to the international requirements, which is an incredible 6,000 pounds force per square inch.
With the development of flame-resistant material has enabled Viking to increase the protection level dramatically over the year. In the beginning, where we were using wool, we had to stand outside the building and extinguish the fires. Today, with the new fabric which we have, enabled the firefighter to penetrate and enter into the building and actually extinguish the fire inside the building. This ensures that we can do it much faster, and also the risk of the firefighter is lower.
After all the material tests have been completed, the suits can then be finished. From the inner moisture barrier to the specially designed outer layer, which is easily removable to help with comfort and reducing risk of contamination after fighting fires. The company make many different variations for use on oil rigs out to sea or for firefighters tackling blazes on our streets. To make sure their clothing is as safe as possible, Viking take up to 8 hours to produce just one suit.
A fire protective garment actually gives a high level of protection. The suit itself is designed to protect a firefighter in extreme exposure, which means a full flashover. This means that the firefighter will be exposed completely to fires. Put into terms, it's actually the suit protects you up to 1,000 degrees C for approximately 8 seconds, where we assure that the firefighter will not get harmed. We also have tested the suit can withstand up to 250 degrees C for approximately 5 minutes, also without any harm for the firefighters.
Made in Denmark and distributed and used all over the world in the most hazardous of places, fireproof clothing, truly a wicked invention. Originally, it was nature's way to give protection to the hunted or allow a predator to stalk its prey, but camouflage has now found its way into the fashion on our high streets. This most distinct of patterns may have arrived in society via the armed forces, but its use was a relatively recent military adoption.
If you look before the 20th century, military uniforms were incredibly bright. They were full of blue and gold and red and white, and that really represented that kind of visual theatre aspect of the Napoleonic Wars. And when we think about the emergence of camouflage in the 20th century, it's quite a sobering reminder of the way in which warfare changed. So at this point, the men needed to be really well concealed. You think of trench warfare, you needed to blend in and be as inconspicuous as possible. And that's where we see camouflage really coming into its own, these shades of khaki that were made to blend into the landscape.
Introduced into the British Army in India in 1848, khaki was one of the earliest attempts at creating a standardised type of camouflage uniform. Named after the Urdu word for soil-covered, Khaki dress reflected the fact that the effectiveness of a camouflage uniform depended on the environment it was to be used in.
In Arctic conditions, you want something that is whites, possibly greys, maybe a little bit of beigey colour in it, depending on the conditions. For night operations, then people wear balaclava helmets, they black themselves out. It breaks up the outline, and it doesn't necessarily make it impossible to see that the person is there. But it is preventing the enemy making a correct analysis of what you're doing or where you are or what you are. So you can start fooling the enemy by adopting the appropriate clothing.
In addition to adopting their colour to help you blend into your surroundings, artists were drafted in to use their expertise in shape and colour to design patterns that could break up shapes and fool the observer. In World War I, the French named their military artisans camoufleurs, which was thought to come from the Parisian slang term meaning to disguise, and which gave the world a name for this military trickery: camouflage. It was not just soldiers' uniforms that were undergoing the camoufleurs treatment.
If you have a battleship or a tank or otherwise, and the painted colours are different than the actual shape of the tank, so don't paint the tank all in green, you paint it in a mixture of colours of greens and browns and light browns depending on the terrain it's going to be around, that fools the eye, which is who it's intended to fool, into thinking it's not quite the shape of a tank, or not quite the shape of the battleship, which might be in blues and greys, and depending on the weather it's going to be in maybe a little darker colours. They're all designed to fool the eye and make it harder to target and harder to spot.
So there is science behind camouflage design, but also a fair amount of artistic license, which might explain the attempts to hide great warships by painting them with bold, dazzling designs.
In the First World War, they had a thing called dazzle for disguising ships, which was geometrical designs, very, very prominent, bright, black and white designs painted on a ship. And you'd have thought, well, that makes it absolutely obvious that it's a ship in the middle of the sea. But what it did was make it very, very difficult for a submarine, in the short period of time it had to use its periscope, to work out which way you were going. And I've seen an experiment done that convinced people that a boat was proceeding at right angles to its true course, simply because of the way in which these stripes worked on the thing. So it's not necessarily concealment, it is a trick.
A symbol of status, fashion statement, or disguise essential, camouflage has cemented itself into all walks of society, and for that reason, it is truly a wicked invention. It's not just camouflage that can confuse your vision. Here are a few tests that can cheat your eyes and trick your brain. To make this work, you might need to move closer to your television. To begin, let's find your blind spot. On the screen you can see a cross and a red dot moving towards it. Close your right eye. With your left eye, look at the cross. You should see the red dot in your peripheral vision. Keep looking at the cross with your left eye. The red dot will move from left to right and disappear, and reappear as the dot moves into and out of your blind spot. Amazing, but why does it work? At the back of your eye lies the retina, which contains lots of photoreceptors that can detect light and convert it into electrical impulses that are fed to your brain via the optic nerve. Your blind spot is the area on the retina where the optic nerve exits the eye. This area does not contain photoreceptors, so any lights that hits this part cannot be detected, and so the red dot disappears. Seeing is believing? Maybe not. What about the eye playing tricks on the brain? Look at these 4 coloured boxes. Cover your right eye, and with the left, focus on the white dot in the middle for about 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, shift your focus to the empty white space. Did you see an image? You should have seen the boxes again, but in different colours. This is because in the retina of your eyes, there are 3 types of colour receptors that are most sensitive to either red, blue, or green. When you stare at a particular colour for too long, these receptors get tired. When you then look at the white background, the receptors that are tired do not work as well. Therefore, the information from all of the different colour receptors is not in balance, and you see what is known as a coloured afterimage. So there you go, Mr. Tester. Seeing is not always believing. Throughout history, warfare has spread from the land to the ocean, with navies battling it out on the high seas. The common thread that links the trireme of ancient Greece to the man of war of the Napoleonic era and on to the high-tech warships of today is the use of rope.
Military have long made use of ropes. They're an extremely useful hard-wearing tool. So the military have used them to rig equipment, to use when they are navigating different terrains, so for climbing or abseiling. They use them as tow lines. And obviously, one use that other people might know of today that aren't in the military is using ropes for military training, so constructing these very elaborate rope military obstacle courses.
Rope success is not just confined to the military. In fact, it might seem a simple invention, but rope has been a vital part of civilization for thousands of years.
Our first fossilised fragments of ropes have been found to date back about 17,000 years, which means that the usage of ropes and knotting predates even the use of the axe or the wheel, for example. Probably in sort of the prehistoric era, ropes were used for hunting already, for building shelter, sort of very early tent-like structures, for use for rigging, pulling things, harnessing animals, tying up people for whatever purpose. So there really was a huge amount of things that the ropes have been used for a very, very long time. It's probably one of our most primitive tools.
So, why is rope such a fantastic tool? Rope's greatest property is the large amount of tensile, or stretchy force, it can cope with. The reason for this is all down to the rope's construction.
When a rope is built, you take a series of strands of cord or whatever fibre you have, and you start to intertwine with one another. This intertwining helps each of the rope's cords to pull against each other. And this pulling against each other strengthens the rope because you're not relying on one specific strand of cord to relieve all the tension. You can allow the tension to be distributed evenly amongst all the cords. For a lot of natural fibres, the twisting action of twisting the rope allows them to coil in a specific way. Hemp, for example, if it's twisted to the right, produces a much stronger material because you're taking into account the natural molecular structure or fibre structure of hemp and allowing it to interleave and be much closer and much more tightly packed. This again allows you the rope to have much better strength.
Lifting weights, suspending bridges, or rigging a warship, rope is truly a wicked invention. The town of Hailsham in the UK has had a long history of rope making, going back hundreds of years. Marlow Rope has been established here since 1807, making all kinds of rope for the military, industrial, marine, and many more industries.
Marlow Ropes is a UK producer of rope for a range of different markets. Product ranges from less than 1 millimetre in diameter with a break load of a few tens of kilograms, all the way up to maybe 100 millimetres in diameter with hundreds of tons break load. Approximately 45% of our business is in the yachting markets. The rest of the business is split up into defence, industrial, and that covers many different markets, from tree surgery, industrial access, vehicle recovery, tow ropes, many different applications.
One of the most popular ropes in the world is made with a fibre called Dyneema. Dyneema rope is much stronger and safer than the equivalent steel rope, and it is now the rope of choice among many industries. To make this wonder rope, 17 rolls of Dyneema are placed onto a frame, with the ends of the yarn being put into a twisting machine. It is twisted together to create a single larger yarn, which will be the right size for braiding the new core of the finished rope. The finished rolls of twisted yarns are then wound onto bobbins, which will be added to the braiding machine. Once the bobbins have been wound, they are then loaded onto the braiding machine. This giant machine weaves 12 threads of fibre from the bobbins at a time, with the end result making a strong 12-strand core. The type of core is determined by a computer, which can be set to produce a multitude of different rope specifications, depending on its end task.
When we develop a rope, we have to work with the properties of the material that we're going to make it from. So a rope like Dyneema, we have a very high strength material. It has very good abrasion resistance, low elongation, good resistance to chemicals and things, but we still have to get all those properties out of the fibre and into the rope in a way that it can be used. So in the case of a rope like a Dyneema yachting rope, we need to convert those very fine fibres into a rope construction that can be spliced. We need to ensure that the rope is going to be compatible with the deck hardware, with the clutches, with the winches, with the jammers. It has to endure the environment on the boat. Many of the challenges are in the compatibility of the product that we make with the application that it's going to go into.
The new braided core is then taken to the coating line, where a worker attaches one end of the core to a roller and switches it on. This pulls the core line through a tank of polyurethane liquid and then through a tight, pre-made knot that drains any excess liquid away. The polyurethane binds the fibres together, improves abrasion resistance and increases friction, as well as giving it a colour. Once complete, the line is hung up to dry. Next is the strengthening process. Here, a different core is being fed into an oven. At a controlled tension, this coated core will be heated and gently stretched, which will improve its strength and reduce stretch when in use. Here we can see two cores which show a before and after. It's the core on the right that has been heated and stretched. Before the core thread can be covered, cover yarn has to be made. This is done by using a ring twisting machine, where fabrics such as polyester and technora run from the creel and into the ring twister. It combines the two yarns and produces a yarn which can be a multitude of different colours. This is then moved onto a winding machine, which winds the cover yarn onto braiding bobbins, so it can move on to the next and final step.
Dyneema ropes are used in any application where you're looking for high strength and low stretch. They're often used to replace steel wire. So we supply Dyneema ropes into winches for vehicles, whether that's a civilian 4x4 or a military vehicle for recovery purposes. In fact, for things like deep water lifting, it's in very deep water, the weight that you can lift with a steel wire is severely restricted because the weight of the wire itself takes up most of the winch's capacity. But changing that to a Dyneema rope means that that full capacity of the winch is available at every depth.
The braiding machine is loaded with up to 24 different bobbins of cover yarn. Each yarn has to be placed and attached by hand first, cutting away any excess. The core that was made earlier is fed through the machine, and the top threads of the cover yarn are attached. When the rope is turned on, the core and the cover yarn come together and completes the finished rope. The finished rope can either be reeled and packaged ready to be sent out, or it can be spliced into smaller lines and made into accessories. Regular strength tests are also carried out. Here we see a cut of finished rope that has been attached to a 30-ton tensile machine. The rope finally gives way at just over an impressive 13 tons. Dyneema rope is now found all over the world, but it doesn't end there. The rope is also being used on the NASA spacecraft Cassini, which is on its way to orbit the moons of Saturn, over 1 billion miles away from Earth. Rope, truly a wicked invention. So there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day, but have never realised their amazing background. Fire-resistant clothing, camouflage and rope, all wicked inventions.